Hello, friends. Hello, friends. Welcome to the world of matrices. In our previous videos, we have understood about what is a matrix, the types, the basic operations. So, going further, let's learn about a new concept that is determinant of a matrix. What is the use of actually doing it? Determinant is basically required to find the inverse of a matrix, right? And what is inverse? That we'll be learning in this particular video. Okay. Now, basically, what we are doing is that we are trying to have a matrix. When we are multiplying it by its inverse, we are going to get the identity matrix. So, for equation solving, we need the concept of inverse. Okay? And for inverse, we need the concept of determinants. So, all are going to be connected. Okay? To give a recap, matrix is a kind of a grid or a arrangement of rows and columns, right? This can be rectangle, it can be a square. Fine. Types of the matrices that we have discussed are your square, rectangle, row, column, diagonal, scalar, identity, and so on. Right? We did the operations of addition, subtraction, and multiplication. So now let's, and the transpose. So now let's go to determinant part. So what is happening that every square matrix has a unit scalar value that is called as determinant. We represent determinant A by det A or modulus of A. This is the most common symbol that we have. This is not the positive of A. This is actually representing determinant of A. Right? So, if the matrix A is 1, 2, and 6, 5, as you can see the representation in the form of a bracket. But if I find the determinant, the representation will be in the form of bars, standing bars, because this is going to fetch me a scalar value, right? A number will be obtained after we solve this. Okay. So if A, obviously it's 1 cross 1, the determinant will be defined as the value, it's very clear. But if A is n cross n, the determinant will be defined in order of n minus 1 or less. Before we understand determinant, there are certain concepts called as minors and cofactors. So once we understand what are minors and cofactors, then we are able to evaluate determinant. First, let's understand the term minor. So if a matrix is n cross n, that is a square matrix, then we delete one row and one column. So the resulting matrix is called as a submatrix. Okay. Now determinant of submatrix is called as the minor, and we represent it by Mij, where I and j corresponding to the deleted row and column. Right? So if I have A11, so that means I am deleting ith row, that is I equal to 1 and j equal to 1. Okay? And the determinant that we obtain, that is called as the minor. So, for example, if I have this matrix A11, A12, A13, this is a 3 cross 3. So, if I delete the first for A11, if I delete the first row and the first column, so this obtained will be called as the submatrix, that is 2 cross 2 submatrix. This will be called as minor of A1. Similarly, if I have to find A12, so in that means I am deleting the first row and the second column and so on. Okay, so we have A21, A23, A31, and A33. So I'll just do it for you. If I have a matrix A11, A12, A13, A21, A22, A23, A31, A32, and A33. Right? So if I have to find A12, I am deleting the first row and the second column. So what I'm left with? A21, A23, A31 and A33. Similarly, we can proceed for A13 also and for all the rest of the elements. Now, what exactly is the cofactor? Cofactor is the sign associated with the minor. And how we identify the sign? We have -1 to the power I plus j. So if the number is C11, so it will be -1 to the power 1 plus 1. C12, the power will be 1 plus 2. C13, the power will be 1 plus 3. So for your rescue, what I'm going to make it here, if I have 1, 1, so -1 to the power 1 plus 1 will be what? -1 to the power 2. That is going to fetch a positive sign. So the entry will be M11 same. For the second entry, it is 1, 2. So the power will become 1 plus 2, which is 3. So -1 to the power 3 is what? -1. So this will give me minus M12. If I proceed, the third number is M13. So -1 to the power 1 plus 3, that is -1 to the power 4, the sign will be positive. Next will be what? Minus M21, because 2 plus 1 is odd. This will be 2, 2, same positive. Then this will be M what? This will be M23 minus sign, because 2 plus 3 is 5, an odd number. Then we have M31 positive minus M32, that will give a negative, M33 positive. So if I say, the sign will look something like this. Okay. So we are having negative sign. So if I get the value, the minor value as let's say 4, then the positional sign will depend on the cofactor -1 to the power. Right? Okay. So how to calculate the determinant? Determinant is actually calculated by multiplying A11 with corresponding C11, because what? C11 is what? M11 with the sign. C12 will be minus sign of M1. Okay, as we have learned in the previous one, C13 will be same as M13, because we have the symbol that Cij is equal to what? -1 to the power I plus j into Mij. Okay. So we are multiplying A11 with C11, A12 with C22, and so on. So it is a sum of the products of the elements of the first row and their corresponding cofactors. Okay. So we are basically mostly use the first row, or you can say the first column, anything you can use it. First of all, we need to understand about the basics of, you can say, the how to calculate cofactors, which is the same as what we have done. So if I have a 2 cross 2 matrix, obviously C11 अगर मुझे इसको करना है तो हम लोग इसको करेंगे, what we are left with A22. So corresponding cofactor will be A22. If I have to find for C12, so we are deleting the first row and the second column, and we are left with this entry, that is A12. But the sign will be what? Negative. So determinant that we are going to solve is going to be A11 multiplied with C11, A12 multiplied with C12. So this is going to be my final result. Okay. Let's do this. If I have a matrix like this, okay, so in short, as we have learned, this will be A11 with A22, the diagonal, minus this cross element, right? So in short, we are multiplying 3 with 2, 1 cross 1 with a negative sign. So this is a cross multiplication. So this is the easiest form of learning a 2 cross 2 determinant. I can give one more example. Let's say I have A as 5, 6, 7, 8. Okay. So determinant of A will be 5 into 8 minus 6 into 7. So what we have is 40 minus 42. The answer is -2. So determinant can be positive or it can be negative both. Let's say I have a 3 cross 3 matrix. So if I start with the first row, for A11, I am deleting the first row and the first column. I am left with A22, A23, A32, and A33, right? So what we are getting, this is going to be the corresponding cofactor. Okay, that is simple, the cross multiplication. Similarly, if I go for C12, but we have to remember the sign. So this is what? Minus of cross multiplication. For C13 again, but the sign will be positive. Fine? Okay. And we are multiplying this with the corresponding first row. We can take first row or we can take first column or any of the column. The determinant will be same throughout. That is a property that we have. And for our convenience, we mostly use the first row or the first column, but we have to remember with the corresponding cofactor with which we are multiplying. Okay. So let's do this with an example. Let's say they have, for we have the first entry as 1 and the corresponding cofactor will be 2 into 1 minus 3 into 0. Second entry will have a minus sign, 0 into, right? So we have the cross multiplication, that is 0 into 1 plus 3 into minus 1, right? Then we have plus 1 multiply. If I'd use this one, so I'm deleting the first row and the third column, I'm left with just this square. So this is 0 comma 0 plus 2, minus times 2 into minus 1, right? So what we have is 1 into 2 minus 0 minus will be 0 plus 1 into 2 minus 2 into minus 1 is 2. So I am going to get 1 into 2, which is equal to 2, minus 0 plus 2, which is equal to 4. So the value of the determinant for this particular matrix will be equal to 4. Okay. And as we have discussed, determinant is a value, matrix is a representation. So you should always remember that the difference between matrix and the determinant. Fine? Okay. For inversion, we need one more thing that is called as adjoint matrix. So a cofactor matrix that we have, and that is a square matrix, we all know, because we are taking the, the determinant of a square matrix only. Fine. So what we are taking? We are taking the transpose of that cofactor matrix, right? So when I take the transpose of that cofactor matrix, the matrix obtained will be my adjoint matrix. Okay. So the adjoint matrix is nothing but the transpose of its cofactor matrix. Okay. And for a 2 cross 2 matrix, if I have, so we know that 2 cross 2 matrix, we are having nothing but, the reversal cross multiplication. So what we have is, this will be 1 times 4, then minus of 3 cross 2, that will lead to the value 10. And this will be the determinant. So if I have a cofactor, I have to find the cofactor. So 1 का cofactor क्या रहेगा? That will be 4. Deleting 2 का cofactor क्या रहेगा? What? It will be 3, because we are taking the negative sign का negative, that is positive. अगर -3 का हमको कोफैक्टर लेना है तो that will become -2, और 4 का कोफैक्टर will be 1. If I take the transpose, this will be 4 minus 2 and 3 comma 1. So this will be called as the adjoint of the matrix A. Okay, so this is the cofactor matrix. There is one more shortcut. Okay, so one more shortcut for a 2 cross 2 matrix, which says that if A is equal to A, B, C, D, then adjoint of A will be D, and A will have a reversal role. We are going to have minus times C and minus times B. So that is your shortcut for a adjoint matrix, because directly we can also do, or in shortcut we can also apply the same. Okay. All right. Now, if I multiply A with the adjoint matrix from left or from right, right? The output that we are going to get A times adjoint A. If I multiply adjoint A with A, now since they both are the square ones, so the conformability issue will not be there. And if I multiply with a determinant with I, all the three will be equal to the same. Okay, so this is a property that will help you to understand the concept of inverse later, because A times adjoint times A will be equal to determinant of A into I. Okay, right. Now let's come to matrix inversion. So, when I have a 2 cross 2 matrix, ideally what exactly is inverse? Inverse is adjoint of A divided by determinant of A. Okay? So, as we have discussed in the previous one, as we go for the shortcut of 2 cross 2, so what we will get? If I have a matrix A, B, C, D. First of all, we define the adjoint matrix. Adjoint will be what? Reversal D A here minus C minus B here. And if I take determinant of A, the result that we are going to get will be called as A inverse. Okay. So the shortcut says simply exchange the elements of the main diagonal, change sign in the elements of it and divide by the determinant. Let's take an example. I have this one. A is 2, 3, 4, 1. So adjoint, what will be there? Reversal of A and B, that is 1 and 2 here. Sign change minus 4 minus 3, right? And if I take the determinant will be the cross multiplication, that is 2 into 1 minus 4 into 3. So it is what? Minus 10, so 1 by 10. So this will be your A inverse. Okay. Now, if I have to check, so check inverse means that if A inverse is multiplied with A, whether from left or right, the output will always be simple identity matrix, which you can see from here. Multiplication we have learned. So 1 times 2 plus what? It will be minus 3 times 4. So we have 2 plus what? It will be 2 plus minus 12. It is what? Minus 10. That will be the first entry. Similarly, the second entry will be 0. Third entry will be minus 4 times 2 plus 2 times 4, which is minus 8 plus 8, which is again 0. Then minus 4 into 3, that is minus 12 plus 2, that is 10. Since the whole entry is divided by the determinant, so what we get is minus 1 with minus 10. So we get plus 1, 0, 0, 1, and that is nothing but the identity matrix of order 2 cross 2. Okay. So this is the simplest way to calculate your inverse. And the check can be done with A times A inverse will always fetch to identity matrix. Now, as we have learned this rule in the previous slides, so this from this result we get, if I multiply throughout, we get that A inverse is nothing but adjoint A by determinant of A. So ideally what we are doing, we are multiplying throughout with A inverse. So what we are having, A times A inverse will lead to I, right? So adjoint A, तो हमारे पास सेम रिजल्ट आएगा. अगर मैं पूरे को अगर A इनवर्स से मल्टीप्लाई करूं तो मेरे पास क्या आता है? A adjoint A inverse, right? Right, and so on. If I move on, तो हमारे पास determinant of A से divide करोगे तो हमारे पास same result. Okay. If you want me to do the proof, I'll do it for you. From this we get A adjoint A 1 by determinant of A. This will be 1 upon determinant of A into adjoint A into A. This will be simply I. If I multiply throughout by A inverse, right? Pre-multiply and post-multiply. So A inverse of A with 1 by determinant of A into adjoint A, right? If I take this, A inverse times I. When we multiply anything with identity, we get the same thing back. So this will be A inverse. This is identity. This is 1 by determinant of A into adjoint A. So what we are left with, that is 1 by determinant of A into adjoint A will be equal to A inverse. So this result has been obtained by these two results that we have solved. Okay. Now this is something which we have done already, that if I take the pre-multiplication or post-multiplication of the inverses, then the output is going to be identity. So it's very clear from here, so you can solve it. Okay. Now let's go for a 3 cross 3 matrix. So 3 cross 3 matrix determinant we have learned. We can take the first row or the first column or any row or any column, that's totally our value. I have zero point 0.3, right? So if I take 3, the leftover minor will be 1, 0, 2 minus 1. Multiply, we get as minus 1. And if I go with the second one, so after solving, you get the determinant is equal to minus 2. Next, we check the cofactors. Cofactors, I give a recap. This is the position of minus sign. So the first one will have the same sign that we had. Second position will be changing its sign, and so on. So after that, we have the cofactor matrix. Take the transpose, that means interchanging of the row and the column. Then whatever matrix we get, that will be called as the adjoint matrix. Divide by the determinant, that will be called as inverse. Okay, so for always remember that whenever you solve your inverse, you need to check A into A inverse is equal to A inverse into A is equal to I. That will actually ensure that whether you have done the calculation correct or not. Okay, but remember that the determinant of matrix should not be 0, because if it is equal to 0, so that will be 1 upon 0. That means no real solution. So that means the inverse will not exist, right? So determinant has to be not equal to 0. This is the most important condition that we have to keep in mind while calculating inverse. Okay, and non-singular matrices have non-zero determinants and singular matrices have zero determinants. So I hope that you have learned something today. We are done with your basics, your matrix inversion, your determinants, your cofactors. So I hope